Hey, John here. Today we're going to be talking about polymers. Let's get started. What are polymers? Polymers are large molecules made up of many small units linked together chemically. They're essential units for everyday life, both internally and externally. They are found inside the body and in common everyday objects. If polymers are both in my body and in some of my everyday objects, how are they formed? They are formed both synthetically and naturally. They're often formed by a double bond and a monomer being broken, which then reacts with a similar monomer to create a chain-like structure of the same monomer. Common polymers that are inside the body are polysaccharides, proteins, and DNA. Polysaccharides are condensation polymers formed from several hundred to several thousand monosaccharide units. Glycogen, starch, and cellulose are the most common polysaccharides found in the body, starch being in animals and cellulose being in plants. Glycogen is a storage form of glucose in the human liver and muscles. These glucose molecules are polymerized together to store these energy molecules for later needs. Starch is a polysaccharide that is found in the human body. It is a pretty popular type of food we eat. That's because 50% of our food energy comes from starch. Starches are made up of two types of alpha-glucose polymers, amylopectin and amylose. Starch is broken down in thousands of glucose molecules to provide energy for our body. Cellulose is very similar to starch. Instead of the human body, cellulose is found in plants. Cellulose contains long unbraided chains of glucose units, about 10,000 per chain. It differs from starch because instead of the glucose molecules being linked together in the alpha position, the glucose and cellulose is linked together in the beta position. Even cellulose looks very similar to starch. In this figure on the right, starch is on top, binding together with beta linkages, while cellulose is on the bottom, being linked together with beta linkages. They might look similar, but humans cannot digest cellulose. Humans lack the enzyme needed to catalyze the hydrolysis of beta linkages. If we can't digest it, why do we eat it? Well, have you ever heard of fiber? Fiber is undigested cellulose. So, cellulose, starch, and glycogen are all polysaccharides, which are a type of polymer. Another type of polymer is protein. Proteins are polymerized amino acids. Proteins can polymerize into fibers, creating hair, muscles, and skin. Other proteins can be found in the body's digestive system. DNA is also a polymer most people are aware of, whether or not they knew it was a polymer. DNA is also known as a polynucleotide, with the monomer being nucleotides. Millions of nucleotides are polymerized together to make up our entire human genome, who and what we are. Quick review. So, just a recap of all the polymers that are inside the body that we talked about so far. We have DNA, which are polynucleotides. We have proteins, which are polymerized amino acids. We also have polysaccharides. A few examples we covered were glycogen, starch, being in humans and animals, and cellulose, being in plants. Now that we've talked about common polymers that are inside the body, let's talk about the common polymers in the world. So this is a list of synthetically polymerized chemicals that create a variety of common objects. First off is ethylene. Ethylene polymerizes polyethylene, which creates our bags and toys. Propylene polymerized is polypropylene, which creates our beakers and our milk cartons. Vinyl chloride polymerized is polyvinyl chloride, also known as PVC. You've probably heard of this. We have our pipes and our floor tiles and coatings or coats that are made out of this. Acrylonitrile polymerizes polyacrylonitrile, PAN, which is in many of our rugs. Styrene polymerizes polystyrene, which makes making cast articles using a transparent plastic. Methacrylate polymerize is plexiglass or leucotate or acrylic resins, which are high-quality transparent objects and latex paints. Tetrafluoroethylene is polymerized into Teflon, insulation, bearings, and pan coatings. Well, there we go. We have our polymers. Thanks for watching.